Okay, folks, here we have a question about an open-ended pipe, and we're looking at the statements about the standing wave which is formed in the pipe. Take a second to have a read, have a try, and when you're ready to see the explanation, hit play. Okay, so as I've said in the introduction, this is a question about open-ended pipes. Okay, it doesn't specifically say anything about the mode that we're looking at, and so therefore we're looking for a general statement which covers all modes, everything that could possibly form in our open-ended pipe. Now, just as a refresher, this is what the modes, the first three modes of oscillation look like in a cylindrical tube which is open at both ends. And you should be aware that at both ends we've got an antinode forming. That is the key point about these different boundary conditions, is that wherever you have an open end, you will form an antinode. So if we have a little look there through some of those statements, I'm going to start with statement C, which says that there's always a central node. Well, if you look at the fundamental mode, absolutely there is a central node. And if you look at the third mode, absolutely there's an central node. But then if you look at the second, you will see that this is the formation of an antinode. Okay, so we will see that as we go through those different modes from the first to the second to the third, we go from node to antinode and then back to node and then back to antinode again. So we can never say that there's always a central node, but similarly, we can also say there's never a central antinode. And so therefore, we rule out two of our options. Okay, so we're left with a kind of sums question, which tells us that the sum of the nodes plus the number of antinodes is an odd number or it's an even number. Well, hopefully we can see the system here that in each case, we're going to have to add together our values of antinodes and nodes. Okay, now, if we notice here, we've got an odd number of antinodes, for example, here. Okay, we've got one antinode here, 2 and 3. Then we notice we've got an even number of nodes. We've got 1, 2 nodes here. And so therefore, when A is odd, N is even. But then also the converse is true when we have an even A. So for example, on the top here, even number of nodes there, antinodes, sorry, we're going to have an odd number of N. And so therefore what we're doing is we're adding together an odd and an even number, which therefore also makes an odd number. And it doesn't matter which of the modes we are dealing with, we're always going to get an odd number. And so that's why in this case, the answer is A.